Hi folks, we're taking a look at our last video on Unit T, two sample tests. And in this particular one, we're going to jump away from doing tests about differences of means to looking at differences of proportions. So we've got a two sample test for the proportion from two different populations. And so the null hypothesis is that the proportions are equal against the alternative that they're not equal, or that one is greater than the other. So it could be a one-sided test, or it could be a two-sided test. Of course, another way of writing the null hypothesis is that the difference between the two is equal to 0. As in the one sample test for proportions, the distribution of the differences of proportions follows a normal distribution as long as the parameters are large enough. Specifically, remember we had that n times p naught is at least 5 and n times 1 minus p naught is at least 5. Well, now you've got two proportions here, so n1 times p1 naught is at least 5, and n1 times 1 minus p1 naught is at least 5, and the same for the second population here. Because P1 naught and P2 naught are often unknown, the sample statistics can be used instead. So you could use P bars here in this particular case. All right. And that's typically because we are just looking at whether there's a difference between the two proportions. We may not have a hypothesis as to what they actually are, just that there's no difference between them. All right. The sample statistics are just your usual way of calculating a p-bar is just the number of successes x over n. So p1 bar and p2 bar. And what we do actually is we come up with a pooled proportion. It's a pooled or combined sample proportion for the two. So you just simply add up in the numerator the number of successes, and then in the denominator the total n here. The test statistic looks like this. And of course the numerator here just has p1 naught minus p2 naught, and that disappears because it's typically equal to 0. Now there is a section down here that says, we're going to take a look at this here. If the null hypothesis is of the form p1 minus p2 is equal to some number k other than 0, then you should be using this more generalized one here. And if you, in fact, had a hypothesized value as to what those p1 naught and p2 naughts are, then you would actually put them in there and use that. However, we don't have that, and so what we would use instead here is just simply, you could put in here just the p bars. Now instead what we're going to do is we're actually going to use this guy up here. I've got a statement here that says, rather than using the pooled standard deviation, we'll use the more generalized form. Actually, we're not going to do that, because in the Excel output I do use the pooled standard deviation, and so that's a statement I actually want you to take out from there. Okay, so really we're going to be jumping from here down to here now. Excuse me. And take a look at the endpoints for the confidence interval for the difference of proportions. And that is just your typical form of a hypothesis that looks like that. And then we've got that. So a difference of proportions, and then you've got a margin of error based on a z value, and then a standard error of the difference of proportions. All right, let's take a look at the following here. Consider the stats 101 data set and test to see if there's a difference in proportion of male smokers versus non-smokers and female smokers versus non-smokers. And so the Sample results then show 28 out of 60 of the female students are smokers. So what we've got here then is a P bar for the females is equal to 28 out of 60. And what is that come to? Do I have that number there? Actually, I don't think I did do that as a decimal value there. I just kept it as the fraction there. That's fine. And then for the males, it's equal to 10 out of 40. Of course, that's equal to a quarter. Right there. And so that's the proportion of smokers, right? That's an important thing to keep in mind here. All right, now let's take a look at how that works. First of all, we're going to do a quick check here. And that check is, we're going to ask the question here, is the N for the females times the P naught. Actually, we're going to use the P bar because we don't have that. The P naught, is that at least 5? And in our particular case, then we'll have, that's going to be 60 times 28 over 60 is equal to 28. Check. And then we would say 1 minus, we'll use the P bar here, is that at least 5? And we'll have 60. And then what's left over here is, I guess it's 32 out of 60. So that'll be 32. And then we could do the same, or we have to do the same actually for the males. So we've got here, let's do it this way. Is that at least 5? And so we're going to have here 40 times 10 out of 40 is equal to 10. Check. And then NM times 1 minus P bar M, is that at least 5? And that is 40 times, well, whatever's left over, which is 30 out of 40. And so that turns out to be 30. So check, 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 check. And we are good to go. So let's take a look at what this thing looks like then. So we would have HO, that the P, not the P bars. Remember, the P bars are the samples proportions, and we're testing the population. So the proportion, and this is of smokers, right? So remember, the P stands for smokers. The proportion of smokers for males is equal to the proportion of smokers for the females against the alternative that they are not equal. And so then we do our check, and what happens is we end up with a Z formula that looks like this. And we'll use the one which is the P bar of M minus the P bar of F over, and then we use that pooled or combined P bar times 1 minus the pooled one. And then there's just an adjustment here for the N's. Like that. Okay. Step number 3 is we're going to have our critical value here. So this follows a Z distribution, standardized normal, and we'll assume here an alpha of 5%. So of course we will put in half of that here. Oops, I guess that would be 0.025. Like that. And those, of course, are plus or minus 1.96. You've seen those lots of times before. Right there. So if your Z star is less than minus 1.96, or if Z star is greater than positive 1.96, then we would reject HO. Okay, let's calculate the combined proportion. And that's actually really easy. You just simply add the numbers together. So we had 28 out of 60 plus 10 out of 40. So 28 plus 10 over 60 plus 40. And that comes to 38 over 100, or 0.38. So that's your pooled standard deviation. Now what we can do is we can, this is part of step 4 here. Let's continue. I'll just change colors here. Z star is equal to your P bars. So we've got, I guess I've got, in my formulas, I got the males before the females, so let's do it that way. We've got 10 out of 40 minus minus 28 out of 60. Okay. And then down here we would have 0.38 times 1 minus 0.38, which is 0.62, times 1 over 40 plus 1 over 60, like that. Okay, and that turns out to be, what do we get? Minus 2.19. So that falls right in here, like that. And so what we do is we end up rejecting HO. Like that. And what that shows us here then is that females have a higher proportion of smokers than the males. 28 over 60 is greater than a quarter, right? A quarter of 60 would be 15. And so it's almost twice that. Like 30 over 60 would be 50%. So it's closer to 50% than the 25% for the males. So that's what we've got there. All right, let's build the confidence interval. And that is, it's on the next page here. So we would have, we're going to take the PM bar minus the PF bar, like that, plus or minus the Z alpha over 2 value, which is just the 1.96. And then we have the PC bar times 1 minus PC bar, and then times 1 over N M plus 1 over N F. So that gives us, what does that give us here? We would have, the males is 10 over 40 minus 28 over 60 plus or minus 1.96. And then we're going to use our, I made a mistake. I got to back up here because we don't use that guy there. We're going to use for this. Oh dear. I got to do this part over here. Okay, so now we take a look at the confidence interval, and we're going to be using this guy up here. We won't use the pooled proportion. We'll just use the original proportions there. And so what we're going to have then is P bar M minus P bar F plus or minus Z alpha over 2. And then we'll have here P bar of M times 1 minus the P bar of M over the N for M plus the P bar for F times the 1 minus P bar for F over the N for F. So that is going to give us over here 10 over 40 minus 28 over 60 plus or minus 1.96. And then we're going to have 10 over 40, which is 0.25, times 1 minus that, 30 over 40. That's a 40 there. Over 40 plus, we've got 28 over 60 times, what would be left over? 32 over 60. And that's all over 60 there. And so that will give us a difference here of minus 0.217 plus or minus a margin of error of 0.184. And so that will look like this. It will be minus 0.40 is the difference between the males and the oops, those are proportions, not M. Those are not mu's. Those are P's. Is less than 0.03. And that's what we've got there. Sorry, that's a minus 0.03. So both of those are negative, and that supports the hypothesis above. These could end up with slightly different answers here, because here we used a pool standard deviation and here we didn't. And but that's how we're going to do it here. Now, let's take a look at Excel. And in Excel, it's a little goofy, because what you need to do here is, obviously, you make a copy of the data sheet, and then what you do is you convert all the students who are smokers to 1 and all the non-smokers to 0. And then you're going to come up with the two columns here for the males and the females. So you'll have a column of males and then a column of females that look like this, and there'll be, you know, zeros and ones and zeros and ones and so on like that. So you have columns of zeros and ones. But these came from the smokers column, right? So you have to convert the smokers into zeros and ones. And then it will work out quite nicely. What you do is you need to add them up here and come up with proportions. So if you add these guys up here, of course the number of males turned out to be 10, and then we had 28 for the females, and that turns out to be 38, and that's 38 out of 100 in total. So our pooled standard, our pooled proportion, sample proportion, was 0.38. And so then what you do is you multiply that 0.38 times 1 minus 0.38, and that'll give you 0.2356. So that's a bit of a pain, but you need to do that here. All right, now that's take a look here and we go to the z-test here, z-test 2 sample for means. Now, we don't have one for proportions, but when you've got columns of zeros and ones, then if you add up and if you average that particular column, that's the same as just simply the number of x's over n. So that is the proportion. You average a column of zeros and ones, the proportion is the mean of that column. So it still works here. And so this is then the column for the, well, in this case, I think it's the females I had first here. And then this one is for the males. The difference is 0. And here's where you put in here the 0.2356. So that was that 38 of all the students then are smokers. And so 0.38 times 1 minus 0.38 is 0.2356, and you have to stick that in there. And you stick it in here as well. So the variable 1 variance and the variable 2 variance. And that gives you your pooled standard deviation, your pooled proportion. This is your labels, this is your alpha, your output, and this is what we end up with. So this is your proportion. So 28 out of 60 is actually about 47%. 10 out of 40 for the males is 25%. And what we end up with is a t-value of 2.187. Now, in this particular case, I had the males first, so that's why we ended up with a positive number. I had the females, sorry, I had the females first here. Up here, I had the males first, and that's why I ended up with a negative. But it's the same number. It's 2.19, which you're going to be comparing to a 1.96, and so you end up rejecting HO. Here's your p-value, of course, which is right there of 0.029, and that's less than your alpha of 5%, and therefore you reject HO. All right. The last thing I want to mention on this is that took a lot of work, didn't it, to do that? Is there a better way of doing this? Well, if you take a look at these two variables, the gender, of course, is nominal. Smokers is nominal. Why couldn't you just simply do this as a little 2x2 contingency table? So you got females, and you got males, and you got smokers, and you got non-smokers. And what you would find out, actually, is that the results that you get are exactly the same. So if you did this as a chi-square test, you would find out that the p-value would be 0.029. It also turns out that this particular value here, if you were to square that, so 2.187, if you squared that, that's equal to the chi-square star value. And, in fact, if you square this particular guy, you'll get 3.84, which is the critical value for a 2x2 table. Where did it go? For a 2x2 table here. So 1 degree of freedom. So in other words, you end up with exactly the same results if you do this as a test of independence. So why would you do it this way? Well, if you're just testing that the two proportions are equal, and you're using the pooled standard deviation, there's no advantage at all. You might as well just do this as a test of independence. However, if you are testing that the difference is equal to some other number, like k, so they're not equal, but that the difference is equal to some amount, that one proportion is, say, 5% more than the other, or if you have the hypothesized values here of what the proportions are, or if it's a one-sided test, then this is actually better. So this is a better test here then if those things apply. However, in our case then, when we're just simply looking at a two-sided test, whether these two are equal or not, which is what we had down here, and we used a pooled standard deviation, pooled proportion. I always say standard deviation, but I mean proportion here. Then there's no difference here. You might as well just do this as a test of independence. But I would like you to know how to do this. And that is where we're going to end this particular lesson. And in fact, that takes us to the end of the unit. So thanks for listening.